Today I am going to solve the questions from 4 to 6. Now question number 4. In question number 4, it is asked, using the rules of bracket algebra, prove or evaluate the following. So let us prove the first question. Question number A. 4A. In the question, it is asked to prove trace of xy is equal to trace of yx. Let us first assume a eigen base case which is B, and this base case follows the completeness relation or closure relation. That means this equal to identity operator. Now trace of xy is equal to b xy b summation over all base cases. Now let us use this closure relation is equal to b x into identity operator y p p x summation of b dash b dash p dash. Here we use the completeness relation or closure relation. This is equal to summation of b comma b dash bra b x get b dash into b dash y p. Since these two are generally complex number, so we can interchange these two. That means we can write it as b dash y p b x p. We can write these things because these two are the numbers. As if a is a number and b is a number, the multiplication is commutative. So ab is equal to ba. So similar, this commutative relation of any number we have used here. Since these two are numbers, so used this commutative relation between two numbers. So this means now again use the completeness relation. Now this means b dash y p summation of b p x p dash. This means b dash y identity operator x p dash, which is nothing but p dash y x p dash. This means trace of yx. Hence we prove the first part of the question, that is trace of x comma y, x into y equal to trace of y times x. Now let us solve the second question. In the second question, it is asked that prove x y dagger is equal to y dagger x dagger. So let us prove that. suppose that y acted on a ket gives another ket vector beta. Now x, y, alpha means x beta. So dual correspondence of these will be beta x dagger. Now the beta means the dual correspondence of ket beta. Ket beta is equal to y alpha. So what it is dual correspondence? Dual correspondence will be alpha bra alpha y dagger. That means beta bra is equal to alpha bra y dagger. If we put this value here, then we will get the dual correspondence of xy alpha. Dual correspondence will be alpha y dagger x dagger, and from this we know that its dual correspondence is alpha xy dagger. This means alpha y dagger x dagger should equal to alpha x y its dagger. That is actually x y its dagger means y dagger x dagger. Hence we prove the second part of the question. Now let us solve the third part of the question. Here it is asked exponential of I f a is equal to what in the bra form, in the ket bra form, where a is the Hermitian operator whose eigenvalues are known. So let us solve the question C. In question C, it is asked that express the operator exponential of I f of a in terms of bracket form. And another given information is a operator is an Hermitian operator. Hermitian operator. So we know that for Hermitian operator, the all eigenkets are orthogonal to each other. All eigenkets are orthogonal all eigenkets are orthogonal. Now we can make these orthogonal eigenkets as well as orthonormal also. That means we can write the eigenkets of A in terms of orthonormal eigenkets. And we know that with any set of orthonormal eigenkets, suppose alpha, we can span the whole ket space. That means if alpha is the eigenkets of the Hermitian operator A, then we can span the whole eigenkets in terms of the eigenkets. That means this A also follow the closure relationship or the completeness relationship. Summation of A is equal to identity operator. Now let us focus if we operate exponential I f of A on an eigenstate of operator A, what we will get as eigenvalues? So let us expand this exponential function, that is identity operator plus I f of A plus I f of A its square by 2 factorial plus I f of A its cube by 3 factorial plus so on. It will operate on A. Since f is a function of the operator A, if it will operate on A, it will give back f of A and A. That means this will give us 1, since identity operator operate on the any state, give 1 plus I f of A plus I f of A its square by 2 factorial plus I f of A its cube 3 factorial plus dot 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 so on. From this form of this expansion, we realize that it is nothing but the exponential series of I f of A. That means the eigenvalue corresponding to the eigenkets A of the operator exponential I f A is exponential I f A. Now let us express this operator in terms of Kedra form, that is exponential I f A is equal to summation of A exponential of, since it follow the completeness relation, exponential I f of A summation E dash A prime. That means it will give A exponential I f of A prime. This will give A comma A prime, summation over A comma A prime A. This will give exponential I f A as a number and A dash. So that will A comma A dash exponential I f of A prime A. Since these are orthonormal state, that means this equal to delta A prime. That means that summation will become a comma a prime exponential of I f of a prime delta a prime. That means it will look like a exponential of I f a. So this is the form of the given operator in bracket form. And from this expression we can easily see that it is a diagonal matrix if we represent it in terms of matrix, because its non-diagonal term is 0. Now let us look the last part of the question 4. Here it is asked to prove that summation of a prime psi a prime star x star psi a prime x double star, now where x a prime x prime equal to, where psi a prime x prime equal to x prime a prime. So here it is asked express it in terms of x prime and x double prime. So let us do that. In the question it is asked summation of a prime psi a prime star x prime psi a x double prime psi x a prime x double prime is equal to, and they given that this means psi a x means a, let me give that x prime a prime, give that x prime a prime x a, that means it will be psi a star x will be a x, that means here a prime x prime into multiply x double prime a. Since these two are nothing but, since these two are two complex numbers, that means these two are commutative, we can exchange these two numbers. That means a prime x double prime a x prime. Since a is a orthonormal base case, that means it will follow the closure relation summation of a x prime, it will give x double prime identity operator x prime, that will give x double prime x prime. So we have solved the question 5. Let us go in the next question. So now we will solve the question 5. In the first part of the question 5, it is asked consider two cates alpha and beta. Suppose a prime alpha comma a double prime alpha and so on, and a prime beta comma a double prime beta comma so on are all knowns, where a prime kate and a double prime kates form a complete set of base kates. find the matrix representation of the operator alpha beta in terms of basis. Since these k vectors form a complete set of base cases, that means it will follow the completeness relation, that means equal to identity operator. So suppose R equal to alpha beta, that means if we use this relation we will get a alpha beta times a prime a prime a prime, so that will equal to a prime a alpha beta a prime a prime. Since these two are complex number, so we can interchange these two number, so that means a alpha beta a prime alpha a prime. So that means in matrix representation R will look like R ij, the ij element of the R operator, that means ij element of the alpha beta operator will be ai alpha beta aj. So we have solved the first part of the question. Now in the second part of the question it is asked, we now consider a spin half system and let alpha and beta be sz equal to plus h cut by 2 and sx equal to plus h cut by 2 respectively. Write down the explicit the square matrix that corresponds to alpha beta in terms of sz diagonal basis. So here it is asked, here in the question, B alpha is equal to sz equal to plus h cut by 2 and beta is equal to sx equal to plus h cut by 2. As we know that sx can be written in terms of the base case of sz operator, that means sx it can be written as 1 by root 2 sz equal to plus h cut by 2 plus sz equal to minus h cut by 2. So now let us calculate the R11 element, that means sz equal to plus h cut by 2 into alpha, that means sz equal to plus h cut by 2 into sx equal to plus h cut by 2 beta aj. Here aj means sz equal to plus h cut by 2. It will give 1 and the second part will give, let us check, the dual correspondence will be 1 by root 2 into sz equal to plus h cut by 2 plus sz equal to minus h cut by 2 into multiply sz equal to plus h cut by 2. Since these two are orthogonal, it will give 0, but these two term will give 1, so that means it will give 1 by root 2. Now let us calculate the other term r12. It will give sz equal to plus h cut by 2 into sz equal to plus h cut by 2 into sx equal to plus h cut by 2 times get sz equal to minus h cut by 2. It will give 1 and the next will give 1 by root 2 sz equal to plus h cut by 2 plus sz equal to minus h cut by 2 sz equal to minus h cut by 2. This will also give 1 by root 2. Let us calculate r21, which is equal to sz equal to minus h cut by 2 sz equal to plus h cut by 2 and sx equal to plus h cut by 2 sz equal to plus h cut by 2. Now the first term will give 0, that means the total term will be 0. Now let us calculate r22. It will also sz equal to plus minus h cut by 2 sz equal to plus h cut by 2 sx equal to plus h cut by 2 sz equal to minus h cut by 2. The first term again will give 0, that means the total term will be 0. That in the matrix form, now alpha beta, that means sz equal to plus h cut by 2 and sx equal to plus h cut by 2 in the matrix representation will look like 1 by root 2 r11 1 r22 0 r21 0 r12 1. So hence we solve the first part of the question 5 and also second part of the question 5. Now let us solve the question 6. In the question 6, it is asked, suppose I and j are the eigengates of some Hermitian operator A. Under what condition we can conclude that I plus j is also an eigengate of A? Justify your answer. A I is I is an eigengate of the operator A and j is also an eigengate of the operator A. That means if we operate on I plus j, we will get I plus j, which is not equal to, this is not equal to I plus j. That means in general this state I plus j is not an eigengate of the operator A. But suppose that the I and j are the degenerate eigengates and corresponding eigenvalue is same. That means if a I is equal to I and also a j is equal to I j, that means these two states are degenerate state. Degenerate state. Then a I plus j will be I plus I j. That means I plus j j. Here we can clearly see that this I plus j is an eigencase of the operator A and the corresponding eigenvalue will be I. That means if the I and j are degenerate eigencates of the operator A, then I plus j is become an eigengate of the operator A. Otherwise, the I plus j is not the eigengates of the operator A. Question 7. The statement of the question 7 is as follows. Consider a Kate space spanned by the eigengates A prime Kate vectors of a Hermitian operator A and there is no degeneracy. Then we are asked to prove that multiplication over A prime, A minus A prime is a null operator, where this A prime is the eigengate corresponding to the eigenvalue corresponding to the eigengate A prime. Now let us prove the first part of the question 7. A, this is the operator A minus A prime. Suppose an arbitrary Kate xi, and this xi can be rewritten in terms of the eigengates of this Hermitian operator A. That will be A prime xi, or equivalently A xi. Now if we operate this operator on this state xi, we'll get summation of A prime A prime A psi is equal to A prime A minus A prime. Since A is a eigengates of the operator A, that means it will give us A and the state will remain same A psi. Now let us look at this multiplication A prime A minus A prime. So here we will multiply all the possible values of the eigenvalue of the operator A. That means sometimes we'll get A prime equal to A. Suppose this is equal to A1 minus A prime dot dot dot. At some point we'll get A prime minus A prime times again an minus A prime. These are not equal to A prime, but sometimes we'll get this term A prime minus A prime, which is 0. That means this product whole will become 0. Every time will get 0 for any value of a. That means this sum will become 0. That means this operator by a prime a minus a prime is a null operator. Null operator. Now let us check the second part of the question, that is P. What is the significance of the multiplication a minus a double prime by a prime minus a double prime, where multiplication over a double prime except a prime? Here the operator is by multiplication over a double prime not equal to a prime a minus a double prime by a prime minus a double prime. If we again operate this operator on the state xi, we will get is equal to summation of a xi by a double prime not equal to a prime a minus a double prime a prime minus a double prime a. Now let us look this term closely. So if a is not equal to a prime, then this multiplication will become 0. Why it is 0? Because if a not equal to a prime, that means when we will multiply over a double prime will take 1 once the value a. When the a double prime will become equals to a, then that term corresponding to the multiplication will become 0. That means that term will become a double prime minus a double prime by a prime minus a double prime. That means that term corresponding to this whole multiplication will become 0. And since one term in the multiplication if becomes 0, then whole multiplication will become 0. That means if a not equal to a prime, then this term will become 0. Now let us closely look at when a equal to a prime. When a equal to a prime, then this will become a prime. The sum will not be there since this only one term. Xi multiplication over a double prime not equal to a prime minus a double prime by a prime minus a double prime into a prime. Now we can see that every term of this multiplication is become 1. That means every term of this multiplication will become 1. That means this whole multiplication will become 1. That means this will become a prime xi times get a. That means this operator will give us equal to a prime a, which means this operator is nothing but a projection operator projection operator projection operator which projects out the term corresponding to a prime ket. Now let us check the third question. C. Illustrate A and B using a set equal to a z of a spin half system. Now here we are asked to explain the whole things. If a is equal to a z, then the corresponding eigenvalue will be plus h cut by 2 and minus h cut by 2. Then the operator, that means a multiplication a minus a prime will become here is z minus h cut by 2 times is z minus of minus h cut by 2. That means is z minus h cut by 2 into is z plus h cut by 2. Now operate it on a arbitrary state xi, which can be written as plus xi plus minus psi. If we operate it on this state, we will get is z times is z plus h by 2 minus h by 2 is z plus h by 2 plus psi plus is z minus h cut by 2 is z minus plus h cut by 2 on minus plus psi. The first this operator will operate on this state will give is z minus h by 2 plus h by 2 plus psi. Now this state will operate on this state will give now operate in this state. Now in the second term is z minus h by 2. First this term will operate on this term will give us minus h cut by 2 plus h cut by 2 minus plus psi. That means it will give 0, and when this operator operate with plus, it will give plus h cut by 2. Then this first term will also become 0 plus minus h cut by 2 into h cut by 2 plus psi, and this already becomes 0 and here it becomes 0. That means this operator is a null operator. Now let us check the operator a multiplication a double prime minus a double prime not equal to a prime a minus a double prime a prime minus a double prime. Now first let a prime equal to plus h cut by 2, then we will get s minus h cut by 2 is z pi a prime h cut by 2 minus a double prime will be minus h cut by 2. So then this operator will become this equal to is z plus h cut by 2 h cut. Now if we operate with this operator with the state xi, what we will get? We will get is z plus h cut by 2 pi h cut plus psi plus minus psi. That means it will keep h cut by 2 plus h cut by 2 by h cut plus xi, and on the second term it will give minus h cut by 2 plus h cut by 2 by h cut minus psi. This is 0 and this is 1 h cut by h cut. That means it will give, that means that operator is z plus h cut by 2 by h cut operator is a projection operator which project the state corresponding to the eigenvalue plus h cut by 2. Similarly, the state corresponding to minus h cut by 2 will be z minus h cut by 2 by minus h cut by 2 minus h cut by 2. That will be z minus h cut by 2 by h cut by 2 h cut by minus h cut. If we operate the state operator in the state xi, what we'll get? We'll get is z minus h cut by 2 by minus h cut into plus psi plus minus psi. First we'll get plus h cut by 2 minus h cut by 2 by minus h cut plus psi. Second we'll get minus h cut by 2 minus h cut by 2 by minus h cut minus psi. That means this will become 0 and that will become minus psi. That means this operator is a projection operator which projects the state corresponding to eigenvalue minus h cut by 2, which is this. So we solve the problem 7.